Assalamu alaikum everyone. This is Probability and Statistic for Engineer course in the Department of Civil Engineering, International Islamic University. In today's lecture, we will talk about Introduction to Simple Linear Regression. Simple linear regression is a very important topic in the field of engineering as well as in other social sciences field. It is actually mathematical modeling, or we can call it statistical modeling, to determine a relationship among various variables. So let's start with regression analysis. Okay, before going into the details of regression analysis, you also need to know about correlation or correlation analysis. Now, correlation is used to measure the strength of the association between two variables. If we have two variables, okay, now if we have two variables, x and y, like in this graph we can see here the graph below, that on x-axis we have square feet, that is area, that is on x-axis, and on y-axis we have the price. So price and square feet or area is the so we can see here that for every value of x, any value for any value of x, there is a corresponding value y. Okay, let me use a pen, and we can see here that this point has a corresponding value y. Now same for the other points, and you can see here that all these points are in increasing order. If x increases, y also increases. So there is a positive correlation between different points, and this shows the strength of relationship. These points are close to each other, so this is a kind of strong relationship between these 2 points. Now we have used a scatter plot, and we can use scatter plot as a first check about the relationship between two variables. Now if instead of y we have x value, and we have an equation where we embed x and that give us y, so that is known as prediction of y, a prediction of one variable based on existence of another variable, and that procedure is known as regression. So here we will discuss about regression now. Regression analysis is used to predict the value of dependent variable. We have two type of variables. One is dependent variable, that is y with us, and we have based on the value of at least one independent variable, and that independent variable is x. Now it explains the impact of changes in independent variable on the basis of dependent variable. So we can predict that how y varies, how y change with the change of x. Now dependent variable, the variable we wish to predict are explained, that is y, and the independent variable is the variable that is used to predict or explain the dependent variable. So y always depend on x, and x is independent on y, so we can call x as independent variable. Now let's talk about simple linear regression model. Now, what is simple linear regression model? If we have only one independent variable x and that affect a dependent variable y, so in that case we call it simple linear regression model. And also we have x to the power 1, so we will be having a linear relationship between y and x. If x has a power 2, so in that case it will be no more linear and it will be 2-degree polynomial, it will be a quadratic one. So the relationship between x and y is described by a linear function in case of linear regression model. Changes in y are assumed to be related to changes in x. So if x changes, then y will change. Now, before going into the detail of regression analysis, let's discuss about different type of relationship that are possible in case of simple linear regression when you have one dependent variable and one independent variable. Now, if we see the first graph, in that case, as the value of x increases, the values of y also increase. So this is a kind of linear regression. If we have different data set and we draw a line which is known as best fit line, so this best fit line, if we draw that, which pass through all, which we don't need to pass through all these points, but it will be kind of representation of all these points. So as this line is increasing, so that is a linear relationship, but positive linear relationship. Now if we have value of x that are increasing and at the same pattern value of y decreasing, so that relationship is also a linear relationship, but that is negative linear relationship. Now we have another example when the value of x increases and y also increases, but at certain point increase in x causes reduction in the value of y. So in this case, the y will be no more linearly related to x. Y will change with the value, with an increase in value of x, and same in this case. So with increase in x, y value increases, but there is no linear increase, there is an abrupt change somewhere here. Okay, we can also see that if in case of linear relationship the points are very close to each other, in that case the relationship is very strong. And same for the negative relationship, if these points are very close to each other, this is also a strong relationship. But if these points are away from each other, then the relationship for increasing as well as for decreasing, the relationship is weak relationship. Now how about the case when you have a data set where the increase in the value of x show a trend where points are also falling along x-axis, but there is no specific increasing or decreasing pattern? So in that case we can say that there is no relationship between x and y. So these are some kind of relationship. Now simple linear regression model, we have a journal form of simple linear regression model as y is equal to beta naught plus beta 1 x plus epsilon. Now here x and y are independent and dependent variables respectively, and beta naught and beta 1 are constants that represent, now beta naught represent y intercept and b1 is the slope of line, which is also a coefficient of independent variable. Now if we have a data set, observed data set, and by using that data set we develop a model. Now for a data set, if we have a y value and we also determine, I call it y observe, and I also determine y predicted, which is based on this equation. So if I obtain these two values, one is observed, might be in the field or by lab experiment, and another y I obtain by using this equation. So the difference between predicted y and observed y will be error, that epsilon is an error. So the more the error value, there will be more difference between predicted and observed values, observed y and predicted y, and it means the model is not a good model. We need to have this error as small as possible. Now if you see this equation, this is basically an equation of line. As I said, x and y are dependent, independent and dependent variable respectively. Beta naught is slope y intercept, and beta 1 is the slope of this line. Now error term is the value of y that fall on that line, which is the predicted value of y, and the observed value of y, which we can just plot on this graph. So the difference between two will give us error in that data. So y height is also, I can also represent y by yp or by y hat. So y hat represent the predicted y which we obtain from this equation. Beta naught is regression intercept, or we can call it y intercept. Beta 1 is regression slope, and x is independent variable. Now how do we determine beta naught? We have some equations for that. If we check, okay, sorry, that is we have beta naught equation, this one, and beta 1 equation, this one. Now if we calculate beta 1 by using data set, that is x is a value that we obtain from the field, that we obtain from experiments, and we can determine. So if we have these values, number of values starting from I to, from 1 to n, we have these value obtained from some experiment, and x bar is the average or mean value of all these values. Now yi that we also obtain by experiments, and y bar is the average of these experimental value. By using by embedding these values in this equation, that will give us beta 1. Now beta naught, which depend on beta 1, okay, this equation is basically beta naught is equal to y bar, which is the mean of y minus beta 1 x bar. So that is not simple b, that is beta 1, which we calculate from the equation. So embedding these different values will give us the predicted y. Now, what is beta naught? Beta naught is the estimated average value of y when the value of x is 0. So if we have value of x 0, there will be a value that will be that beta naught, so that will be equal to y if x value is 0. Now beta 1 is the estimated change in the average value of y as a result of unit change in x, as beta 1 is representing the slope, so it is a unit change, it is the change in the value of y as a result of unit change in x. Now I will talk about a very simple example, and we will determine the value of beta 1 and beta naught to develop a model which will be a model of house price and square feet. Square feet is basically an area, so we will develop a model for for dependent variable house price and for the independent variable square feet, which is the area, and you can understand the logic behind linear regression analysis. Thank you for today's lecture.